Hi everyone, welcome to another episode of the Common Lisp Study Group. I'm your host Ram Vedam with Atlanta Functional Programming. Last week we introduced, in addition to our normal Ask Us Anything, a library that I kind of cursory started looking at towards the earlier in the week. But I haven't provided too much detail in it, and that is the clenvironments API. Today we're going to be discussing more about this API, this library, clenvironments, which is an implementation of the environments API as it was defined by Guy Steele in Common Lisp Language 2nd edition. For those of you who have this book, I encourage you to actually go look at it. I think it was in section 8.5 of that book, where he defines this library. Don't worry, we'll dig into more details of the motivations behind this and things like this. Specifically, early on, I'm going to be kind of summarizing some of the stuff that I read from here. There's not much information about the environments API in general, other than this material here. I haven't, as I mentioned, in the Common Lisp language. But it is a very important facility, so important that some folks actually adopted implementation-specific extensions in their various shapes or forms until this project, clenvironments, kind of came out through and unified them and provided some implementation it provided wrappers to existing implementations of the actual environments API if they existed, and if they didn't exist, it provided some ways of actually filling in those gaps. So you had kind of like a polyfill to actually fill in the gaps where folks who might want to use a different Lisp interpreter, but it doesn't have the environments API provided in its own implementation, it can actually use just using code walking techniques. The history of the environment API and why it wasn't provided in the standard, as I understand it, is mainly related to the fact that some of the notions weren't actually hashed out before the standard was approved. So X3J13, the ANSI committee that actually developed some of these facilities, decided, at least as part of the standardization, to leave it out, because at that time Common Lisp was already kind of getting a little bit large, and so they decided that it might be better off to actually put this as kind of an idea that could be added as a standard later on. Obviously, the community took some initiative and provided ways of actually using this API in various open source implementations, one of which I think, if I'm remembering correctly, CMUCL actually provided the implementation, along with, when I looked into it, there was a couple of other lists that actually provided an implementation for this. And this includes even some commercial lists, like Franz actually provides an actual implementation of the environments API separate from what we will be discussing today, which is the clenvironments library implementation of it. To begin with, we must understand what an environment actually is, and I think that last time when I kind of touched base on this, I didn't actually cover this information, but now reading the section in Common Lisp for Language, I'm beginning to understand why it's important to at least get started about and talk about what an environment object is, so this way we can actually begin to talk through the API. So what is an environment? Well, an environment in a nutshell is nothing more, at least as I understand it, a data structure that contains information related to objects that are in the running image, and they are encoded in a way that they can be received as arguments by macro expansion functions, the macro expand hook functions, and eval hook functions. Now, to understand what that means, at least in terms of macro expand hooks and macro eval hooks, we have to look at the common Lisp hyperspec, which actually defines, macro expand hook as being uh, nothing more than a interface hook to macro expand one to control how we actually expand macros. So, for example, you could certainly define some hooks to actually say log what we're trying to define, what we're trying to expand. For example, the way you would do this right now, and this is all standard common Lisp before we actually dig into some preliminary discussions on this. A hook, example of a macro expand hook. You could define a function, and this is the reference here is straight out of the hyperspec on the subject. If you define a function, say, log hook or something like that, that takes in 3 arguments. Log hook that takes in 3 arguments, the expander that you're actually expanding, the form that you're actually going to be, the expander is actually the object or function that's actually going to be expanding the form. The form is the actual piece of code that we're going to expand, and then a optional environment that will be there. This is important when we start talking about the clenvironments API, because this env, this third argument, is necessary to hold all the bindings of the various variables, functions, and declarations that we talk about. And again, I'll define some of those when we get to it. Once we've done this, we can actually go in and say simply, let's say we're going to just dump now to the console, the code that we've actually created here as a string, and we'll actually, it has an X expression, we dump the code, and then we can just call the expander on the form with the given argument, okay? Something like this, okay? So this is our first log hook, right? So now, if we let's say define our standard typical, let's say we def macro, the standard one that we'd always see, the when, to learn how when is written, and we have some sort of condition, and then obviously the body is going to be our body, and then obviously we can write this as if cond then if we do cond, then we could do prog n, and we splice out the body here, okay? And just to make sure that we do my when 4 less than 5, print okay, and we see that, you can see that we print okay, and if we go ahead and, we do our macro expand, it's just for rectify, just a quick thing. Now, if we wanted to use a macro expand hook, well, all we have to do here is to simply wrap this guy in a let form and then set the macro expand hook. And macro expand hook itself is nothing more than a special variable that you can then change within the context of a function. And we can actually go and say that this is our hook, our log hook. We hook it into the macro expand hook, and then prior to calling this, when we go and do this, for some reason this is not actually dumping out to the standard out. That's weird. Let me try this. in this should work. Hold on. Format T. Okay, so why is this not? I did this. This should actually dump out something. This is weird. Okay, it might be the case that this is one of those things that Sly will not allow me to do, but if I go into the command line, it might let me do it. Let's try this. Shell let's see this, and then we do SBCL. Okay, hold on. D E shell. Let me do like that. Okay. And then it took over my top buffer. Weird. Let's do SBCL. Oh, sorry. I keep forgetting I did not have that. I have to do ROS. Well, which ROS? Which ROS? Okay. User, local, then ROS. Okay. So let's go ahead at this point. Split the screen. Sorry. Split the screen. Go back to what we had earlier in our environment examples. Obviously, we have this first that we want to run. So we can do this, paste it. Okay, so we now have our function. Please don't worry about the indentation. We'll get back to using Sly in just a minute. I'm wondering if this will all kind of like get back to like working the way we expect it to when we do it this way. Okay, so now we have our when, and let's do this. So we do y, and we do this, and we see weird. Huh? That should have worked. Log hook. Let me see if I explicitly say hook like this. Maybe I have to do it this way. That would be weird if that actually is a problem. Because, nope, that's not it. Let me see something here. Oh, I'm being dumb. I am being dumb. This is macro expansion, right? So that's why we haven't seen it there. There, exit. Okay. This sometimes happens. My apologies, folks. So we do this. Once we kind of have this form here, right? We need to not only wrap this in a let form, we also need to call macro expand, like we did before. So this will not work, by the way, because this macro expand hook is not actually hooked into Sly. Okay. That's something to be important to be aware of. The macro expand hook to hook into Sly would require you to actually go in and do the following. Well, but first let me just show this to you here. So we all know macro expand requires you to first, and let me just do this here before we start. Let's do this. And let's go ahead and macro expand this. We all know that this, when we macro expand using this like so, it's going to go ahead and print out the expansion to the console Although right now it's not going to actually do it because when you're doing this in the buffer, it gets eaten up. Standard outs gets eaten up here. So if we go and just wrap this in a print statement and we actually macro expand, we get what we saw earlier when we actually do interactive macro expand using Sly. Now if we just simply change this and, as I was saying, use macro expand hook to log hook, this is what we end up getting. You'll see, hold on one second. Let me just clear this out because it looks like it printed it in the same area. So if we do this, you can see that what the hook is actually doing is it's taken over the expansion and then it prints out what we're actually expanding. Okay. So call expander on the form hook. Normally, it should also print out the actual conditional that we're actually dumping out, but for some reason this is not doing that, which is kind of.
Hey, Ron.
Yeah, what's up?
Is there something similar for macro expand 1?
Right? Yes, this might be it. Yeah, I think I have to do macro expand 1. I think this is why. This is, you can use macro expand 1 as well. I mean, that's the expansion. This is macro expand 1 is the actual function that we should be using. I think that macro expand is specific to SBCL, or macro expand all is also explicit to SBCL. But it's macro expand 1, you're right.
Macro, that's the only one I can understand. If it goes beyond that, I get lost. So I just have to do, like, macro expand 1 on something, and then copy all of that, and then macro expand that one more time. But maybe the log hook function is grabbing stuff before it gets expanded, right? Rather than the result of the expansion.
Well, it should.
Right.
I mean, it's no. That's what it's doing here. It is actually doing the expansion, but it should also call the expansion function.
You're right.
And that's why I'm kind of confused as to why this is.
Right?
What?
Yeah, I mean, I see this substituting in the actual condition and the print okay, right? But where's the if go?
Right. I mean, it's printing the actual code the way it's expected to. I mean, pretty printing it at least. Like, it's basically pretty printing this, like so, But it's not actually giving me what this is essentially doing, right? It's not giving me the actual prog n piece or the if conditional that we wrote.
Sure, you're writing out by hand, right? If you do the expansion by hand, it's just like if, and then the expression less than 4 or 5.
Right. My understanding is the macro expand hook would actually inject itself as part of the expansion, and you are ultimately in control of what should happen here, right? So in this case, we're using funcall to actually call the expander function. Or in this case, the macro expand 1 on the form and the argument, right? The environment object.
Right. I mean, you rerun that let, right? So now the macro expand is log hook, but then within that context, macro expand 1 on my when less than 4 or 5, print okay.
Right.
That whole thing. Have you reevaluated that?
This is so the let hook. So when I have the let, inside the let is a macro expand, right? So it should actually print out. Oh, again, I'm sorry.
Yeah,
I am so sorry.
Do that or react explicitly
No, it's not that. It's what we saw earlier. This is all about sly again. I have to do this. Print macro expand. Because it doesn't actually hook into it. What?
Well, it doesn't do anything with it other than expand it, and then if you don't want it, it just goes away.
Right.
So it goes away at the end of the let expression.
It goes away at the let expression. That's what this is doing. So now we have that. I did this earlier and I forgot about it, and then I was like, wait a second, why is this not working? So yeah. So if we do this, you can see now it's printing the way we expect it to. In fact, let me just.
Oh, sweet! All right.
Yeah, this is actually pretty sweet. So you could do whatever you want actually here. It's kind of clean it up. I'm just cleaning up the output here so that we have kind of a good thing here. It looks really weird here. You see how it gets an indented the way it's doing that, but I think this might be a function of this might be a function of the Emacs buffer holding it. Once I clear it, it's probably adding some extra things into for tab completion. I don't know.
Okay, so I mean that's log of doing that though, right?
What?
So I mean we're seeing the same thing almost exactly the same thing twice, right? So it's now expanding my when, right?
But this is what we were expecting. This is exactly what we're expecting. So let's go through this code a little bit, right?
Sure.
So what we did is
so what I'm wondering, if we didn't have log hook, right? If we didn't even assign macro expand hook to anything in particular, could we still print the macro expand on that thing, and it would probably come out pretty, I would think. The second one, first one is the result of kind of the imperative stuff you're telling it to do, and then the second thing is the result of the evaluation of the entire expression.
So right? Here, if we run just macro expand, we both know the reason why I prefer macro expand, because I actually had to double check this because I was going crazy, because I know the hyperspec mentions macro expand and macro expand 1. Macro expand 1 is only it expands the first level of the macro, right? Macro expand though is the recursive version. It'll keep macro expanding the form until it's no longer a macro form.
Okay.
So if you call macro expand on a macro that itself returns a macro, it's going to call itself again.
Well, you could to be real clear, you could probably call it on a function that returns a macro, right? That then would have to be expanded.
Right.
You got a function to create macro.
I don't know if that would
macro expand, as you said, doesn't. Huh?
I don't know if does that work? Yeah, that should work. Yeah, you might be right.
I think I'm right. I think I played around with it, but this is the kind of stuff that makes my head hurt. But macro expand 1 is the one I always like to use because, I just want to make sure that my first level understanding of what's going on is correct. And
right.
If that's correct, then I can say, okay, let's go look at,
So this.
Then I will just copy and paste. Right?
Just using sly macro expand, you're calling macro expand 1. Let me just put it that way. All right. So
okay.
if you use sly, sly macro expand is always sly macro expand 1. Okay. So there's one thing that I wanted to kind of show as well, because this feature of macro expansion, and this goes into our environments piece, is actually a feature that you can also do in, I think if I do macro expand, it will, no, that's going to do recursively, all in place and all minor. So there's no real way, this is kind of what I kind of expected, but I just wasn't sure. I thought that there was a way for you to register hooks into Sly's macro expansion just basically when it calls macro expand, could you, if it's possible to actually get this kind of stuff? But it looks like that hook isn't there. Um, that's a that's a that's a feature request, but that's a it's one of those things that you learn when you're doing what.
Yeah, I have some feature requests. It'll take a while.
Yes, it's a feature request, but that's probably something that may be low on the priority list for other things, for usability and things like this. So with macro expand hook, we have this ability now to hook into macro expansion. But what about evaluation? Well, that again, we could do the same thing with eval hooks. We can actually log the evaluation. In order for us to do this, is obviously we need to go into the hyperspec again, because I keep forgetting what the signature is for eval, to write an eval hook. I'm assuming it's the same thing. Eval hook, right? So that's an important one that needs to be looked into.
Could you just wrap it in a do?
Wrap it in a do. Wrap what?
Just prog in the result of you're gonna, okay, so what you're getting back is some code, right? So what you want to do is evaluate the code.
Oh.
Eval, but I've always heard eval's so super dangerous, right?
It sounds super dangerous. Well, it looks like eval hook actually does not exist in this. Now I'm kind of curious if this was in the environments API, because I saw this, but I thought it was part of the environment. I didn't think that it was in the environments API. Let's see here. Star E. Nope, only error output. Okay, so it looks like evaluation did not. Okay, so this is why I need to always have to map what's in the Common Lisp second edition with what's actually in the hyperspec. So macro expand hook exists, but eval hooks doesn't look like it exists, which is interesting. I guess that makes sense given the fact that, like you said, it's pretty dangerous if you start being able to inject into the evaluator like some code.
Yeah, but can't you just, hey, like, what this thing's going to do is literally going to print the macro expansion of that statement, of that expression, right? So then, what do you do with the printed?
Yeah, you can always do this, right?
Okay.
And this would work as well, right? Now, do you want to do that? Probably not. It's not a good idea to use eval in code, in my opinion.
Yeah, I agree. So
there are very special cases where eval is necessary. For example, if you are writing a DSL and you're trying to restrict your users to only use the DSL and nothing else. So in that case, the evaluator, the eval, is becoming your user interface, your command line interface for your application or your program. At that point, you could certainly, I think, end up calling eval. I think that's safe. But the way you do it, though, is I think you'd have to first override all the reader methods. You like change name read tables to only have those reader macros that are specific to your DSL, and then after that, prune it so that they can't access anything other than your DSL. So you probably put that in a package that doesn't use, say, CL, for example. And then and only then could you probably maybe use eval just to take in code and then use the rest of the Lisp machinery to go in and do its thing in terms of transformations.
The way I kind of look at it is, level 1 is keep dummies like me from blowing something up, right? And then level 2 is try to avoid sneaky people that are much more skilled than me from from finding a way through your interface to somehow start eval, unrestricted backup.
Right. Right.
Like a hack, So, but I mean, just the first level. I mean, couldn't you? So, print is really literally. Well, print's going to put something out to console, right? And then, or to standard out, right? So then, if we said like we could say read, what would happen if we read the macro expansion? We could then try to evaluate it.
If you read the macro expansion, it shouldn't attempt to evaluate it. It's only the output of the read that will go to eval, right? So unless they have direct access to eval.
Is eval the only thing that can use output of a read?
Yes.
Maybe it is. I don't know.
I'm pretty sure that that's the case.
Okay,
so read will go through a reader macros, which will create its transformations. Then it'll go through macro expansion, which obviously will further expand the macros. So read is actually non-Lisp to Lisp. All right, this is how I kind of like think of it. Read is non-Lisp, maybe Lisp to Lisp. All right, so eval, because that's where you can change. The reason I say non-Lisp or maybe Lisp is default read is a Lisp. All right. So it'll take in atoms, it'll take in symbols, it'll take in S expressions, right? But if you wrote a reader macro, then at that point, especially if the reader macro has been registered into the read table, if the reader recognizes that you're trying to invoke a reader macro, it will then check to see if the reader macro is in the read table. And if it's in the read table, it will use that reader macro's function to expand that non-Lisp syntax, and in many cases it probably non-Lisp syntax, to Lisp syntax. Right. So that transformation is the reader
macro.
Right.
Well, really to be real careful to a syntax tree.
Right, essentially, right. That's exactly what it is. It is a syntax tree, but it could be transformed like source-to-source transformation to something equivalent that's already in Lisp.
Oh, yeah, that's cool. Okay, so, vanilla read expects to be able to transform standard Lisp grammar into a syntax tree.
Right, that's right.
Create other readers that can take other grammars, and they might produce a valid Lisp, syntax tree.
Right.
Or they might not. You're right. They could transpile from, some strange language 1 to strange language 2. Right?
At the end of the day, as long as you stay within the reader, you can keep on going and changing the language and modifying it and optimizing it. Right. Non-Lisp to non-Lisp.
No. It's mind-bending.
Right. You can keep staying in non-Lisp, but eventually, in order for it to be evaluated, you're going to have to convert that non-Lisp form to some syntax tree that represents an S expression that can then be evaluated. Okay.
Yeah. So what I think what you're saying is that there might be a case where we don't particularly want to evaluate the output, other than produce it.
We want to evaluate the output, but we may want to do other stuff. There might be this case. This is where the eval hook, as I understood it, came in. At least, again, this is based on my reading of the Common Lisp Language 2nd edition, right? In addition to get the results of a computation, you may want to do other stuff. All right?
Yeah. I think I agree. It's just that the kind of cool thing is that evaluation by the eval is kind of only a corner case right now. It happens to be the most popular corner case.
Right.
Right. But there are other things that can be done using a reader, which would be, my silly example is transpile PHP to Ruby. Right. Now, if I understand the grammar of Ruby well, I understand the grammar of PHP well, I should be able to transpile them. But that doesn't necessarily mean I want to do anything with the output of that. So I'll give it some PHP and get back to Ruby. But all I'm going to do is put that in a text file and send it something, right? I don't want to evaluate it at all. But I don't need to build, a Lisp AST, right? I'm only using the reader for one of the things accidentally really good for, which is being a general purpose transpiler, right?
Mm-hmm.
It's kind of like there's this incredible amount of more power there that we don't even really think about using, right?
Right.
Feels kind of like what's his name that wrote Let Ever Lambda and his fascination with just the sorry, I seem to be allergic to something. It's like what was I thinking?
Are you talking about Forth? His obsession with Forth, or are you talking about with anaphoric macros? Because he tends to have he had an obsession with a couple of things in that book.
Yeah, he did. He had a number of obsessions. But I mean, one of them is just that starting once you have macros, you're in like not even like the third dimension. You're like, I didn't know that there could possibly be this many directions, this many dimensions, because macros can write macros.
Right.
So now we have functions that can write functions, and we can have functions that write macros, and macros that write functions, and macros that write macros. Now, as soon as you have macros, that's just really powerful. And once you realize that macros can write macros, and you're like, okay, I don't know where to stop. This could go crazy, right? So I think read is kind of similar, right? In order for read to work properly as a Lisp reader, it has to be very powerful, right? And it's straightforward, but very powerful.
So the basic, so here's the thing: the vanilla. This is why I separate read from reader macros, right? Read, vanilla read absolutely. Is only, I think its only purpose literally is to take stuff from standard in. Okay, I'm using the Unix vernacular here, right? Or standard input. If you look at the global variable, the special variable in your environment, it reads from standard input, okay, and then has its parsing it. All right. In the simplest case, it's probably just attempting to parse. It has an S expression. Okay, that's vanilla read. But if during its I'm assuming it's going to have to be character driven. If it encounters a special character that during its lookup in the read table maps to a reader macro, then it's going to invoke that reader macro. I'm assuming vanilla read is actually what it's actually doing, and this might just be me speculating here. I would have to get some verification on this. When it looks at the open paren, it's probably calling a reader macro for open paren, right? So now you have unified everything, right? Oh, open paren, that means I'm doing Lisp read, so I'm going to do Lisp read. If I see, let's say, yeah.
But so yeah, I mean, it sounds like read macros are to read as macros are to function.
Yes.
Right. So there's a function table, right? Then there's the first check, like, well, is it a macro? Right? Which in our case, we can only have one name assigned for either a function or a macro. But if it detects that it's a macro, then it knows, okay, I'm supposed to do macro expansion rather than function evaluation, right?
Right.
That makes sense.
That makes sense.
So then, in the case of read, it's either vanilla read, which is just like things are going to go, as expected, nothing fancy, kind of like evaluating a function. Whereas if there's a read macro involved,
Right.
transform it, and
Right.
then perhaps evaluate it.
Right.
Evaluation might just be printed out or saved somewhere.
Right. No, that's exactly right though. When you said read is to read, read macros is to read as macros is to functions. You're exactly right. That's why I think at some point when we've talked about macros, I kind of used this idea that Lisp itself can be literally used as a compiler framework, kind of much like LLVM,
Absolutely.
because now S expressions is your basis. You don't need basic blocks or all this stuff. It's just yet another compiler macro that could take in your S expression tree, do program analysis on this, and then ultimately spit out another S expression tree. And you can keep going until eventually you have an optimized S expression tree that could generate fairly efficient code. All right, you don't need to, have to go through all these other hooks.
One of the grades, right? It was Sussman or Bellman. He kind of offhand tossed out that, even if computer scientists that he knew all across the country and the world and everything, even if they weren't really in the Lisp or whatever, Lisp S expressions were just a very convenient way to define the grammar of a language and try out new things. So, and it's an apocryphal story that apparently, S expressions were supposedly like a temporary fix, right? Until they could come up with M expressions.
Right, and then M expressions got kicked out because people loved S expressions so much. They started getting this.
Do enough, right? They do enough in an elegant way, right? It looks different from what you expected, but that's only because you didn't see it in the elegant way before.
Right. And S expressions is also one of the advantages of S expressions. And I'm sorry, and folks who are interested in environments, we'll get to environments in just a minute. I just want to kind of no, I think it's an important topic to discuss though. S expressions in many ways is also a universal serialization format, right? You can use it to define a message that can then be computed because then the parser is built in. As long as you are leveraging S expressions, you know that the start of the message is going to be an open paren and the end of a message is a closed paren, and you could structure your data as a series of S expressions, which will define either a structure or an object or whatever, right? It just simplifies the read of that you're defining, the reading of the message when you're sending it across the wire.
Well, I think the incredibly important other point is that given that def macro, a macro defined by def macro takes in text and then expects it to be valid expression. Actually, it doesn't, right? It just will put it in wherever you want it. But then it builds something that then is assumed to probably be a valid S expression, right? Or another macro, which I guess is a valid S expression.
Right.
Right, and then eventually it all gets inflated, and then that thing gets treated as something that can be passed off to eval function, right? So, but the cool thing is that all of this is the homoiconicity of Lisp, right? So I mean, I've written code in Python that can write code in Python, but it always involves stupid tricks like either copy and paste or save it to a file and then read it back in, right? So that's stupid, right? Why have to save it to a file and then read it back in? Just go ahead and read it, right? Or just expect that the output of this layer of evaluation is valid for the next layer of evaluation.
Right.
And that's what Lisp gives you.
So this is straight up from on Lisp chapter 17 read macros, right? Because I had to go and find this. When I first read this, I read this originally on someone else's blog on reader macros, but he pointed me to on Lisp for this, and it actually coincides with the comment that was just made on read macro. Read macro is to read, has def macro is to define, and that is correct and not correct in the case that in the sense that def macro defines a macro, right? I don't know. I don't think read macro is defining a reader macro. I think there's actually a syntax for defining a reader macro. Usually, what you do is you define a function that takes in a stream. The stream is going to be potentially have a list of text. Okay, you're reading in text off the stream, okay, one at a time using the existing API. And then after you define this function that could essentially parse the stream of text, you essentially, for a reader macro, you simply provide some sort of notation to inform the Lisp reader when you should invoke this reader macro. Okay, so like in the case of quote, you can just use set macro character like this. You can. I'm not going to obviously run this and then define this. So you could have some sort of potentially some basic reader that right now doesn't do anything, all right? And you could say that, this is just going to be a declare or ignore for the time being. Stream car. So now we have our reader. And then to set it, you could just use set macro character where you now say, let's use, you have to specify a character here. Let's use maybe, I guess $sign would be probably the best, any better than anything else. And what this does is basically informs the reader to register in the read table that whenever it sees a $sign at the beginning of potentially running something, it will call this reader macro to read it out. So now if you say $A plus B, it's going to attempt to should have attempted to call the read on this.
So you don't have A defined, right?
A.
So dollar is going to invoke your basic reader, which is just going to do nothing and pass it back to read, right?
Oh, right. So I need to define A. So let's define A. Let's just do it this way.
Set up A and B or something.
Yeah.
1 and 2.
Yeah. Let A1 B2, and then just do $, and then quote A plus B or something like this, and then it will attempt to run it, and it's going to try and invoke, I think.
It's still undefined. That's weird.
Undefined function. Huh. Oh, it is an undefined function because it's trying to treat it as a function in that case here. Let's do that. This shouldn't have actually called.
Right, so try the same thing. Why don't you do $sign? Why do you need a quote there?
Yeah, that's what I'm
trying to see. $sign left paren plus AB. Because all the $sign's doing is just passing something normal read, right? So then you want to put.
Oh, no. I know what it is. I realize what I did wrong here. This has nothing to do with this. This is because we haven't actually called the reader. We need to call read first in order for this to actually work. And unfortunately, this is reminding me when we did let over lambda. I think when I do read in Emacs, I get something screwy. Let's see if this works though. Okay, $A plus B. There we go. That works. It looks like they corrected it. So what read does is we need to provide a stream of text to read, right? This is me actually providing the stream of text to read via the Lisp reader, right?
Okay. Yeah.
But read is the function that actually hooks it. It needs to take the stream of text first. You need to provide it from standard input. That's the difference.
So now this is.
Hold on, there's a comment here, but I think reader macros do their work at compile time. No, reader macros do their work at read time. So when you call read, when you're taking in the Lisp REPL, when you call read, when you're calling the actual standard input, at that point you're going to have to deal with it. So if we wanted to do this in the normal Lisp REPL, all right, you could certainly pass in a string, all right. Let's say that let's, and this is probably the best way to do this. You do this. You defun basic reader example that takes in a string, all right? And all this is doing is just calling read. And actually, let me just define this here so everything is kind of nicely in thing on the string, okay? And if we call basic reader example on $a plus b, it's going to, what does it do? Oh, it's not of type string. Right, I'm gonna have to convert that into a stream, don't I? What was it? How do I take string to stream? And why am I having a brain fart? There's a way of doing this in,
like string and a stream?
yeah, is there a make string? Yeah, string input stream. There we go. We just do a string input stream. No, not output stream, input stream. And we could just do, oh, wait.
String, right?
Yeah, but the thing is, yeah, make input string. Yeah, that's what I was looking for. And we could do that. Now, if we call this, you can see that, again, when it triggers that $sign at read time, it's going to say, okay, read table, are there any freaking macro characters that represents this? Oh, the $sign is associated with the basic reader. Let's call the basic reader, right? Okay.
And then it does nothing.
It does nothing. Well, because I defined it to do nothing, right? I could certainly define it to say.
Make it always say. Yeah, just say print boo or something like that, right?
Print. Well, I could do this. Is there a way? Hold on. With open stream with input from string with output to string. No, with input from string is not what I need. That's right. I could just simply do this. Line, read line, stream. Since there's only one thing in this stream, we could do this. Okay. We could just do print line. Okay, basic reader. We're registering what? Oh, wait. Here we go. Oh, sorry. Let me do this. We're getting rid of the character. Okay, now we're good. Now, if I call this, oh, right, I have to go and re-register the basic reader. Once I compile it, it doesn't actually do that correctly. And if I do this, there we go. There's one thing to know about reader macros, and we covered this a little bit for folks who are just joining in on our discussion here on CL environments. We covered some of the stuff on reader macros in earlier episodes when we talked about let over lambda. I encourage folks to go and look at that series. We did a pretty in-depth review on that. This is just all basic review, but it's necessary because a lot of these APIs, if you will, if you actually look in the hyperspec, they all take in this third argument, this partial third argument, which is the env argument, okay, which is the environment object. So one must ask, what is this environment object, and how come a lot of these signatures have it, right? Well, the environment object, as I mentioned, basically is essentially the set of functions, variables, and declarations on those variables. Okay, so declarations is an important key to know. We can, and we'll go through each one of these in just a minute, because declarations allow you to add meta information on top of variables and functions. Okay, for example, we've used actually a couple of declarations already in this in our stream in previous episodes, right? And we even used one just now. Ignore is a declaration, right? Ignore cannot be called as a function. If you recall, we've talked about this before when we talked about declarations. And there's quite a few different declarations out there, one of which is pretty common, and that is optimize. If you want to optimize your code or inform the compiler to optimize your code more towards either safety or more towards speed, you could certainly use declarations to actually go and optimize your code. Okay. There is something that we'd want to be able to look at when we're defining this stuff. But this is kind of the minimal things that are available. These are necessary for macro expand, for if you had eval hook, but it doesn't exactly, it doesn't exist in most implementations as far as I can tell. If you would need it there if you were doing program analysis. Okay, this is a very important use case for the use of environments. You'd want to be able to get this meta information during the course of your program analysis so you can make informed decisions as to how to optimize a particular piece of code. This is particularly important if you started writing compiler macros, which ultimately can be viewed, at least as I view them, has optimization stages, essentially, that's going to take your Lisp code and further optimize it once macro expansion is complete. You now have the fully expanded Lisp program to optimize on. You're now looking at the entire tree at this point. You're probably doing some sort of code walking. This environment object, while it sounds simple enough, like it's something necessary that would be in interactive programming and stuff, didn't have much design. The facilities weren't actually put in place because of a couple of things. One of which, almost the use case that it's typically was used for was destructuring macro arguments. Okay. There is a function that ultimately does this that's available in our clenvironments API. We may not cover it today, but it is a call that allows you to do this kind of destructuring. But when destructuring bind was added into the language, my understanding was they decided not to add parse macro, which is the API call that would have done this stuff. But clenvironments ended up implementing this kind of thing, part of the environment specification, because there were a couple of use cases where destructuring bind could not completely support, just because it wasn't general enough to actually justify actually complicating the particular implementation details of destructuring bind, which is really dealing with, as it says, destructuring arguments. Obviously, there were a couple of things that over the course of standardization that were, kind of came through that prevented such an API to exist, but that doesn't mean that this wasn't going to get published. So this API was documented by, like I said, Guy Steele in Common Lisp, the language second edition, and a lot of folks ended up, after the standardization occurred, taking kind of the helm of his API spec and providing implementations for this. Uh, Commercial Lisp, especially Franz and LispWorks, I think both have their own implementation of the environments. But also there was some open source implementations of Common Lisp that actually included environments, and that includes, I think, again, SBCL and CMUCL, that heritage. I think also there may be something related to, yeah, I don't believe Clasp has it, at least as far as I know. I don't think Clasp has the environments implemented. I encourage you to go and probably do some digging to see if your particular Lisp has its own implementation. But to use it, I think you first want to try out this library that we're talking about today. Last time we kind of covered some of this stuff, so I can quickly go through it. The one thing I'm going to mention is related to what we were talking about earlier, and the fact that there are a lot of these env arguments already kind of spilled over in many of the API calls in Common Lisp. You might realize that they are optional, and yet it sounds like this fundamental object is necessary in order to do program analysis and other things. Well, although these are optional arguments to be passed in, and usually that's the case when you have augmented environments, what that means is, and what I mean by environment being defaulting to nil, is that we're basically informing the Lisp reader and the Lisp environment to use what's called the null lexical environment, or the null environment. Okay, this is the top level lexical environment that contains only the global definitions and proclamations that are present in the actual environment itself, the running image. All right, this will contain all of that information, and the environment object will keep track of that. Okay. Obviously, with the environment object having that, you'd want to have some sort of API to grab this information from the environment object. And these informations are specified by variable information, function information, declaration information. Each of this is its own API call. We talked about variable information, how it provides kind of like three arguments really related to binding, what the binding is, and what its local is, and what the declaration is. But let's briefly review what this is. If we actually end up, providing, let's get rid of this, and let's just do a quick, def parameter test value 3. So if we have like a parameter like test value, or a constant has test value, if we call print variable information, again, this is just doing a multiple value bind on the call to CL environments variable information. We get three values. One, again, is the binding level. Recall it's either special lexical symbol macro. If we call symbol macro let, we'll give an example of that, or constant. The one thing we saw last time is that with lexical variables, at least, we had some trouble actually using this on lexical variables. But let's see if this kind of works for us today. So obviously, if you call here, and let me just go ahead and clear my REPL. Okay, 1 second. User REPL. Okay. If we end up calling, say, our test value here, you could see that there's nothing in here. If we define it, though, we end up getting that it's a special variable. Okay. Obviously, it's not local. What local means is whether or not there is a local binding of that special variable if the name is locally bound. So my guess is if we ended up using this in, like, say a let test value being 5 or something like this, and then we attempt to call PVI on the test value. This is when the second variable, it looks like the second variable is still not being bound to local bindings. So I'm going to have to dig into what local binding the local binding definition means in this case here. That's weird. The third value related to a variable name, as I mentioned last time, is related to an associative list about related to kind of the given the variable, the apparent binding of the actual variable itself. This is a series of specifiers that provide you, like, it's an A-list as to whether or not it's ignored. Some of the declarations are related to. So if we, for example, here said declare ignore test value. Curious if this would work. Test value special variable. Okay, so we can't actually use this for special variables because of the warning. Let me try this here. Oops. Okay. One here, and MCF. Let's see what happens. Oh, let's call print test value. Oh, actually, I don't have to do that. Let's do declare ignore test value here, and let's see what happens. We see that it's set to nil, 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 rather than actually providing information related to that. That's kind of interesting. Let's see something here. Hold on, keep that there. Let me see if I call this directly, what will happen. CL environments variable information test value. Okay. Oh, print. Okay. Right. Okay, that's right, because we have to do that. That's the entire reason I wrote multiple value bind. It's only going to print out the top level most thing. We'll get back to this variable thing. Like I said, for some reason, this is giving me kind of something interesting here. Let me see something here. SB, what was it? AXT. Nope, ENV. I thought there was an SBNV. I'll go look into that, see what the SBCL versions is. So if we go into a constant, like I showed you before, we have now constant, we have now special. Lexical should work, but for some reason we don't have that. Let's say we have symbol macro let should also work too as well if folks have a symbol macro let. I can't think of right now a way of setting up a symbol macro let. For example, let's see. I think maybe I could do, let's say, let's see here. We could do print. So, we could just say, let's say X is some list of foo and bar. Okay, so this is the simplest symbol macro that we're going to be dealing with. And let's say that we do print variable information on X. Let's see what happens here. You see that it's getting nil, nil, nil here. Let's make sure that that's the case here. It looks like that there's some issue with this API's ability to print the variable information, at least as it pertains to symbols and other macros. But let me check something here. Here. That is okay. So let me check one thing here. Let's do this. This should be a symbol test value, but I'm wanting to know if this actually is. So what I'm going to do is do that. Oops. There we go. So now we have that kind of things. And, oh, right, I forgot that. Okay, so here, what I'm going to do is I'm going to do this program. Oh, sorry. When symbol P test value. Let's see what happens here. If this is not a symbol, then this answers that question about why we're getting nils all the time. Because my definition, oops, let's see here. Form due to compilation errors. There's no function called declare. Oh, right. Okay, my apologies. That is because I put in a declaration inside of some Lisp code. So this is what we needed. So, this is interesting. So, what does this mean? This means that although it's a symbol, so just to give you guys what's going on is the documentation kind of tells us whether or not a symbol is in the environment. It's a lexical symbol, special symbol macro, or constant, right? We've already seen examples of a special variable in a constant, okay, as defined by def constant. Lexical symbols, which are defined as by the let, right, as you all know, are still technically symbols, but for some reason, CL environments is not treating them or recognizing them as being lexical symbols. So that seems to be an issue with CL environments. Now, if the author is watching, or if somebody points it out to the author, the one thing to know is that the environment upon which the environment upon which we are actually dealing with right now is still the null lexical environment. Okay, we have not actually even begun to touch this situation or this idea of actually handling uh, augmentation of the environment. Okay, uh, if we end up calling print environment symbol macros here symbol macro let, we know that this is the same issue here, right? We can't actually print out information about this. In fact, I'm kind of curious if I do this, what would happen? Yeah, I figured that it will try and expand foobar. So that's kind of where that thing is problematic. That's kind of weird. Let's go ahead and talk about uh, function information for a minute too as well. Again, I'm just trying to uh, combine a couple of examples here. Although we are using them here, they're still style warnings. We're still reading them, but that's okay. Um, Obviously, you don't want to ignore that which you're trying to use. You could also actually do this. Let's do optimize speed 3, safety 0. Just to show this off to here. What? Wait a second. No, force to do. Oh, right. That's because I forgot to also label these as fixed num AV. Okay, so now let's see what happens. Let's see. Oh shoot. Control C. No. Okay. Let's see what happens here. Note signed word to integer coercion cost 20 for the final result of an inline doing. Okay. We will be okay with this for the time being. So we have our definition of function add. Okay, and suppose we want to actually grab information from this. This is in the null lexical environment. We can go ahead and print this guy out. This will tell us whether or not it has bindings, whether or not it has so whether or not it's a function or a macro or a special form. So in our case, if we simply change this guy here to looking at my when that we defined earlier, you would see that this is actually a macro. This is not a thing. Special forms, obviously, dealing with code like progn. I think these are special forms. These are also can be introspected and looked at and understood as well. These are necessary just so that, again, for program analysis, you can provide potentially information related to this. So the final thing that I wanted to kind of like touch base in this is really just declarations. Declarations, as you know, is that we're talking about are these meta tags that you can use, and there are many of these. But you may want to know or may want to check to see where they've been defined. So in this case, if you do kind of the same thing, let me actually do this in the command line, in the REPL. You can actually call declaration information and ask about a specific declaration, say optimize, okay? And what this does is it returns to a list essentially. of the environment in which it's actually kind of held and all the information related to it. Um, if we call, say, ignore here to as well as another example, you'll see that this is not actually a supported declaration. And the reason for that is um, ignore is not the actual declaration.
Oops, I forgot what we were talking about instead.
1 second. The phone is being stupid. Um, so So declarations are a special thing because declarations in the environment API, you have the ability to actually go and define these kinds of declarations. These are custom declarations that you can add on top of the ones that are provided by the hyperspec. Optimize, like I said, is one of them. There's actually several declarations. Let me just give you kind of a quick idea here. Here, declare was let me actually go back here for a second. This, yeah, this one. So let's check out, for example, say dynamic extent, which is another declaration here. Dynamic extent. Unsupported. Hold on. Let me go and change theme package. CL user. Let me see this here. Dynamic extent is an unsupported declaration. Really? That does not sound. That does not look right. Optimize. Okay, hold on. Maybe I just am messing up the syntax here. Thought I had to pass in a symbol. Environment declare declaration information. Okay, documentation returns by declaration name. If the declaration name is optimized, it will return a list whose entries are of the form quality and value. So, okay, so it's giving you the information about how are we optimizing here. So what we're getting here is actually what are the default settings for the optimize that are specified in the environment. Okay, that makes sense. In the global environment, obviously you want to be able to provide you may want to go and change a couple of these things later on, but if you want to in query to see what's already available, you could certainly use CL environments colon declaration information to get information about what's already been declared. These are the flags that's been passed into the declare form. That's where my confusion came from. Okay, so if if declaration information is that, then let's see what the valid declarations are, which it looks like I just need to pass in declaration instead of optimized here. So let's try that. clenvironments, declaration information, declaration. And we see that declare variables in variable rebinding in PCL class being available here. Okay, so let's go and switch back to this, call declarations. And we see that it's still these variables, optimizers, iterate, declare variables, variable binding, and so forth. So let's see what iterate, declare variables gives us when we pass in declaration information. Okay, so it just told me this. Oh, maybe I don't need this here. Okay. Interesting. This here is, oh, right, let me go down. Thank you. Here isn't giving us the complete list. This is all related to some of these declarations that you're seeing are only at the top level. But they should actually provide you information related to the declarations associated with the given form, variable, or function. Now, the reason, so the declaration information the reason why we didn't see any declaration information related to like constants and test values is that literally we did not declare anything on that. And it looks like for symbol values, we didn't provide any declaration information here too as well. I don't think you could do this, but we could try this to see if we could get declaration information on symbol macrolect, but food bar is not of type symbol. Again, I did that. There we go. And you can see that we have still all three nils. But let's try doing this. Declaim, because I think at the global level you can't use declare, you have to use proclaim or declaim. Let's see here. And again, for folks who don't know what a declaration is it briefly just, it's metadata that the compiler can use later on. And to issue or not issue warnings at certain points. And you can define your own declarations using declaration. So you could do like this declaration. Sample. This is a sample declaration. And later on, we're going to be using define declaration from the clenvironments API to make this more explicit. But you could use declaim because this is at the top level. Declaration. Let's say author. I think this is straight out. This is from the hyperspec. Okay, from hyperspec. What this does is define a basic declaration, which you can now use in a specific function. If you call, though, just to show you that's already in the null lexical environment, declaration information on author. You could see, for example, this, and you'll see that, oh, sorry, I have to also provide a symbol, this, okay, and you'll see that this is unbound. What? Let author equals JK Rowling. Okay, and let's say that we do declare author. Okay, which we can do because we don't do anything here. If we end up calling now, actually, I think we could call now print variable information this on this guy. And we'll see. It does not get nil. It still gets nils. Interesting. Okay. Let's see here. This is a declaration, isn't it? Yep. And this information it can be used later on by, let's say, compiler macros if you're trying to grab this information, provided that I can actually access this. Let's see here. Let's do print cl environments declaration information on author. Author is now bound, so, and it says that it's unsupported, but it's not unsupported. It is user defined, so that's interesting. Oh, it may be though. I have to define this using define declaration. So this is the actual declaration that we normally would use, but this may not be going into the null lexical environment the same way that, say, define declaration expects you to do it. So if we do define declaration, and these other defines are some of which are defined by CL that it inherits from. So declaration name, let's say author, and we're just going to go ahead and generate that. Okay, so we're going to just do this instead. Do I have to specify it as a string? I'll compile time. Too few arguments to an author to satisfy. Okay, let's see what this is complaining about. Oh, let's say that this is, okay, let's do this. Instead of doing declare author, let's do CL environments define declaration author. See what happens. It might be complaining about, yeah. Give me a second. Let me just do this and say author name here so that way we don't confuse ourselves. And let's see what else we have to provide. Optional body. Oh, okay. What this is doing is I have to actually slurp the code that I wrote earlier. And see what happens here. Name. And let's try and see if I can actually slurp the other two too. Okay. Author name, invalid number of elements in author name to satisfy lambda list. Arg optional thing. Oh. Okay. Let me see this. So that is going to be related to let's see here. Author is defined, never used. It is let me see. Argvar. So declaration name is going to be this, and let's say that this is going to be a list. And let's see what happens here. Required argument is not a symbol. Oh, okay, so it is asking for a symbol. Okay. Let's see this. Okay, let's see what this is. So, okay, got it. So this is actually going to be here in this case, author. Code is different. Code is defined. Alright, clear. This is better. Okay, let's try this again. Define CLTL2. Okay, so it's this SBCLTL2. Define the author, declare. Let quote be quote SBCL2. Okay, so do this. Let me see what happens. It still actually is complaining. Let's do quote here and see what happens. Nothing is printed out though. Let quote, print quote on declaration. There is no information about that quote though. Okay, that's right. Because we didn't actually define anything on it. Okay, let's do this. And declare author name. Let's see what happens. This is author name is not of type symbol. Okay. Let's see what happens here. Is that the type symbol? Author name is not of type symbol. When binding declaration name. Let me try doing hard code string for the time being, just to see what happens here. JK calling here, and we have this, and it's going to be a not type symbol because it is obviously not a type symbol. See. Unsupported declaration of nil. Okay. Let's see. Let's make a symbol. Make symbol test. So now it is of type symbol. What is it complaining about? It is not a symbol test. Okay. Let's see here. Quote is not used. Well, quote is not used because the fact that it's generating it here. Interesting. So this guy is complaining. Let's see if this happens. This is what I just wrote. It wrote in the key case. Here we go. Let's do. It's not a variable or expression. So, what is this again? Hold on. It says went through wanted one variable, function, or declare. Let's just say that we do let me read this one more time. The name of the declaration for which to define it. Now here, the name of the variable to which the argument list of the declaration name.arg is bound. Oh, okay. So I misread that in the documentation here. So let's see. Let's do this here. And let's call this name instead. And then let's do this. Let's see what happens here. What is it complaining through? It is complaining about the this. Probably it's complaining about this. So we don't need this. I might be just putting an overkill here. So let's go ahead and get rid of that and see what happens. Nil fell through. EK6 wanted one. Okay. Declaration which should be added to the environment. If a variable is a function, okay, so there seems to be a little bit more confusion for me on this declaration information stuff that I need to go and read into. Just because the global nil, the way this is working, declarations are essentially compiler tags if you're adding. And there's this way that you can go ahead and define a compiler tag. But for some reason, there's a couple of things. One, for existing declarations, which is what I kind of am interested in right now, there seems to be this issue where it's complaining that it's either unsupported or um, it's spitting out information that, as you saw here, when we did the describe, um, it's actually providing the list of declarations that have been proclaimed. But things that are declared are not actually being spit out. So that's number one. Number two, and this might again, if the author is watching or the folks that are watching, okay, let me read this. It works in MySBCL. So there was a comment if I run print variable information with args passed to CL ENVA. So if it's a PVA for special forms. So hold on. So there was a comment about special forms. If I pass in special forms, this is in. So if you the special form stuff works with functions informations. So what you're returning there. Hold on, let me just read the comment. So function information actually does work. If you actually go and look at what I was showing earlier with function information, we can get all the three types of values related to the first arguments or not. So, so for example, here, if we did, let's see here, probably be the easiest way to do this. So we saw prog n being a special form. If we go in, this is special form, we'll see that this is actually a function. We've seen if we go and, do this with our macro as well in function information again, we'll get our macro. If we end up calling, say, you know, what was the other one? So we did function, macro, special forms. Yeah, these are the three that are actually getting written. And if there's no function binding, like let's say we provide, say, something like, say, block or something like that in the environment, and we try to query it, we'll end up getting nil, nil, nil. Okay. The other thing that it can also do is if we provide, say, an flet, let's say, and let's say add 2, that takes x, and provide x plus 2. I think that's kind of the notation that I can use. Let's just double check. yeah, deleting unused function, and we provide, let's say, declare ignore add 2 for a second, and let's say that we try to do this case here with our multiple value bind. This is the other one where you want to be able to kind of call out stuff, right? Because here, what we're doing is we want to know if it's a locally bound function or not. So if we do add 2 here, and we print it out, instead of giving us a nil, 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 I was kind of expecting it to be function true, saying that it's a local function binding for symbol, but it's not giving me that, so that's kind of weird. And if we, obviously, if we, for folks who haven't seen this, add 2 too, we just do that. This all kind of works. But it's not giving me the function information, so that's just kind of the thing here. And yes, the comment about symbol macrolet is defined in the null environment. That is true. So if we do symbol macrolet against here, let's just say I change this to symbol macrolet. If I define this, you'll see that this is a special form. It's going to be in the null environment. That's right. All the standard common Lisp functions and macros are in the null lexical environment. They're imported when you run the image. The things that seem to be somewhat troubling in terms of using this library, at least for the API, is locally bound functions. That is, lexically bound functions and variables for some reason aren't being recognized by the environments API as being lexically bound. And of course, this might be just me making a mistake on how to use this library. So for folks who think I made a mistake in my usage of it, feel free to put comments in the YouTube section and let me know that how what the issue might be, and we can go through that. So we haven't covered as much as, we went on many different very interesting discussions tonight, but there are still a couple of things related to this API that I wanted to cover, but it looks like we're running out of time here. So I'm going to kind of close off by saying there's a lot more to this library, especially when you start digging into kind of the declarations piece that we were trying to dig into earlier. And especially if we start doing environment augmentation. Okay, so there's a comment about difference. Okay, so there's a question here about maybe my debugging of this. It might be a difference between the read time and the compile time issue of the meta information. That's a good point. I don't believe it should be the case here, because the point of the environments API is that it's going to keep track of this information. A lot of this information is actually interned into the symbol object that is actually stored inside of the image. Well, to be more specific, inside of the null lexical environment that's in the top level, right? Obviously, if you create other environments that are lexically bound or package bound or whatever, they're going to have different levels. But specifically, most of the functions that we're dealing with and most of the examples that we've been dealing with up until now have been lexically bound in the top level. And their symbols as such should be in the null lexical environment. So even when you're using a let, or even when you're using an flet, okay, you are essentially taking a symbol and interning it into that environment, and you are running a query against it. I guess maybe in this case, the environment that I accessed is the null environment. This might be the problem. Since we're dealing with the null environment, okay, which is the top level of environment, we're only dealing with essentially anything that's defined at the global level, right? So that only includes anything that's defined with def parameter or def var or def fun or def macro. So anything that's there at that package level at that in that null environment, that's essentially what we do. So what we need to do is we need to first probably define a augmented environment that holds this information and see then if it's locally bound. So this is what I'll probably end with. Let's see here. What should I do for this? Okay. There is just an environment function, but let's see what this does. Describe CL environments in environment. It's a symbol. It defines a macro. Okay, but how do I create a new environment again? Do I need to just do augment environment? Probably. Yeah, I'm gonna have to do augment environment. Okay, so let's look at augment environment. Augment environment is creating a new environment by augmenting an existing environment with new information. Okay, so let's do that. Okay, let's do a let env being cl environment augment environment. Our env, the null environment is kind of what I need to, if I don't provide, if I do not provide, let's see, if I do not provide this, say this is nil, would it grab the top level environment? Let's see, variable, and this is going to be a list, right? Yeah, list of symbols. Let's do this. Let's do a star. Here we go. That's 5. Let's go here and make this X. And let's see what happens. Finally used, obviously. Okay, it looks like this will work. So let's do this also. Okay. So if we have this environment eclexically bound, let's go ahead and declare ignore X for a second here. And what we're going to do is a CL environment in environment. And this guy is going to use env. And let's see what happens here. Let's print variable information on X. Shift, and let me do this so I can clear. Let's see what happens here. And we get an exception, sorry, a condition thrown. Invalid number of, oh, shoot, that's right, because I forgot to add additional, those are all key arguments, not optionals, right? So that's the problem. Okay. So the one thing about augment environment that you probably may have noticed is all these symbol macro, function, macros, and things are all additional definitions that you could provide. So we're not going to provide any of these for the time being, although it might be useful to go ahead and add one for functions and stuff. We'll do that, once we have, let's say, macro my when. Well, my when is already available at the top level, so we'll just say these are empty for the time being. Okay, let's see here. What did I miss? Did I miss anything? Optional environment. Okay, hold on. Let me look at the defaults here. Let's see if I can actually say augment environment. Star eval. This is modules, package, print line, random eval, standard input, standard suppress, read base, query IO, modules, break on signals. Where is, shouldn't be looking in this level, but it might be that they didn't expose something here. Let's quickly look at this here. The existing environment to augment is going to be by default whatever is going to be provided. So let me go look at one of the other functions. Let's try function information here. See what the default is. Optional env. Let me see this. Nope, none of these is actually going to be that. Augment environment is the only thing we need. Let me go do this. Env is going to be let's see if I just provide this, what happens. List. See what happens, and it will complain one or two, but got a non-list. Okay, hold on. Let's see what happens here. Okay, so give me a second here. Let's do this one at a time. So we have this here. If I do this, because we did try this before, this all worked when I used nil, but it kind of got screwed up when I tried to. Sorry. No. and augment. Okay. Then let's go into augment environment. Augment environment. Okay. Name the compile function. Source file. Okay. I think this is right. Hold on 1 second. Oops. Here we go. Here with this, let's see this. In environment, okay, got it. I have to do this. That's what it is. There we go. This should do it. Let's see what happens. Print variable information is unbound. Okay, that's right, because it can't recognize this information right now. So let's do this. We don't need that. Okay. Then print variable information unbound. Let me go ahead and add in our function print variable information. Okay. Let's see what happens there. Unbound. What? Print variable information. Okay. Okay, let's try this way. Multiple value bind. I don't know if this would work, but we will see. Bindings, local declaration to essentially CL environments for variable information on X. Let's see what happens. For multiple value binds is malformed. Okay, that's why. It is complaining because I'm using this as a second argument. That's the problem. Okay. Okay. REST bindings. Ignore that for a second, and then let's see what happens there. Declaration, local bindings, and never used. Of course not. That's because of the fact that I did not define it. Let me see now if I even need to do this again. I don't think I need to. Cut print variable. Because I should be able to use this because of a closure in to the top level environment to actually leverage this. And let's see, I think it looks like it worked, and I'm still getting nil, which is hysterical. Oh, shoot. Okay, 1 second. Do this. Let's start with none of these. We augmented the environment. We're gonna go do this. Now let's do this here. Let x5 Okay, let's see here. Oh, let me pass in the environment in here. That's the problem. I'm sorry, guys. So this is here. What I need to do is, in this case, I need to pass in, I need to adjust my env guy. Because I don't want to constantly type in multiple value bind. So optional env, and all I have to do is here wrap this around here. Actually, I could just do that. This is done, and this. There we go. Now we have it. So now here, if you look at this, what we do is we, in order to get lexical true and nil, we need to actually first recognize that it is a it has to be defined. Locally bound means locally bound to a local environment. Okay, so that's what that definition means. Not locally bound as in being lexically bound to the top level environment. So that's kind of the great thing there. So the only thing left, honestly, is there a way to get this for the lexical environment? In which case, a simple task would be let x5 print variable information x nil, and see what happens, and you'll see that it's going to be nil, nil, nil. So it looks like it does not recognize if it's within an environment object, we actually are okay. If it's not within an environment object, if it's querying the top level object, it does not treat lexically scoped variables as being interned in the top level environment. So it can't actually query for them. So lexically scoped variables can only work within the context of a given environment object instance. So you have to always augment the environment before you actually can go and use it. This is the same if we provide, say print function. We end up doing what we did before with the print function stuff. If we were to define in this environment, say defun add 3 b plus 3, and we go and define here this information, as you can see here. And in fact, we can actually do this entire thing here down in this piece. And with this, we got ourselves some good old-fashioned. Interesting. Okay, so it doesn't look like I could do that with the environment. I have to go in and bind it into the lexically scoped environment too. This goes back to that same problem that we had before. Right, so as long as I'm within that environment, I have to go and define everything ahead of time, import it into the into the null environment, and then it should then scope it, which I think I just did with print variable information, but I don't know if that would actually necessarily work. So let's check this one last thing, and then I'll call it. Okay, let's see this, print variable definition. And we get a function, but it's still related to being at the top level in the nil environment, not the lexically thrown environment. Oh, because I didn't provide the environment. There we go. If I provided the environment, we can actually get that. If you don't provide an environment, it doesn't look it up. If you provide the environment, it does look it up. So that's kind of what it is. So I'm going to leave it at that. There's plenty of more to this library. Define declarations is something we have to talk about. Parse macro definitions is definitely something we have to talk about, as well as some of the additional wrapper functions that are available for augmenting the environment. And I think with that, we could then start writing and start doing some basic code walking in our stuff. So next week, we're going to continue our exploration of this fantastic library. Sorry for a couple of mistakes that have been made. Any errata that you may have found during my coding session today, please let me know. Post it in the YouTube comments so that way I can go back and refer to them, and then we can have a follow-up discussion. And until next time, happy hacking. Thank you.